Triode is a vacuum tube containing three elements, namely a plate, a filament, and a grid. In 1906, Lee de Forest added a third electrode into the diode between the filament and the plate. This was shaped like a grid iron, and he called the electrode the grid. Let's learn about the different types of triode constants which are useful in solving problems. A. Plate resistance is defined as the ratio between change in plate potential to the corresponding change in plate current, keeping grid potential constant. B. Mutual inductance or transconductance is defined as the ratio between change in plate current to the change in grid potential, keeping plate potential constant, required to bring about that change in current. C. Amplification factor is defined as the ratio between change in plate potential, keeping grid potential constant, to the change in grid potential, keeping plate potential constant, in order to bring about same change in plate current. Also, amplification factor is equal to the product of plate resistance and transconductance. Let's solve an example to understand the problems based on triode. Question. A triode has plate characteristics in the form of parallel lines in the region of our interest. At the grid voltage of -1 volt, the anode current I in milliampere is given in terms of plate voltage V by the algebraic relation. I equals to 0.125 V minus 7.5. For grid voltage of -3 volts, the current at anode voltage of 300 volts in 5 milliampere. Determine the plate resistance, transconductance, and the amplification factor for the triode. Solution. We are given that at grid voltage of -1 volt, plate current IP is equal to 0.125 Vp minus 7.5 milliampere. On differentiating the plate current with respect to plate voltage, we get d of IP by d of Vp equal to 0.125 into 10 raised to power -3 ampere by volt. Therefore, plate resistance Rp is equal to 1 divided by d of Ip by d of Vp, which is equal to 1 by 0.125 into 10 raised to power -3. That gives us Rp equal to 8 kilo ohm. Again, Ip is equal to 0.125 Vp minus 7.5 milliampere. At plate voltage of 300 volts, Ip is equal to 30 milliampere. In second case, grid voltage is given to be -3 volt, plate voltage is given as 300 volt, and plate current is equal to 5 milliampere. Therefore, the transconductance at constant voltage is equal to delta Ip divided by delta Vg. Calculating Gm by putting values, we get Gm equal to 12.5 into 10 to the power -3. Finally, we know that the amplification factor is equal to plate resistance into transconductance. Thus, we get μ equal to 100.